So it is necessary that the industry should be fair and equitable for the all stakeholders. So, and it not only provide the incentive for a particular part of the system, it should provide the incentive for all the participants, or you can say that maximize their total profit into the power market. So competition in the market with multi-utility structure, so that is the one of the new term which is added in your power market, that is multi-utility structure. Actually, initially in the conventional power structure, there is a single utility structure, means generation, transmission, distribution. They are connected they are connected for providing the power to the consumer. So that entire structure is known as a single utility. But nowadays, the people are making a group into the system, like some of the generators and some of the distribution company. They can make a set inside the market, and they can transact the power and through various contracts. So this particular segment is known as a utility, which having the generation as well as the distribution company. So if in your market number of utilities are there, so that type of structures are known as a multi-utility structure. So later on we will discuss in a some detailed elaborated manner how we can say that it is a multi-utility structure. And renewable energy is a very important part in this one, because why I have taken this point especially because when the large scale renewables are integrated with the power system, then the multi-utility structure come into the market, and the people are making the contract with these renewable energy power generation system. So we will discuss later on. Now multi-utility structure is, as I said, it is a structure which contains the number of generator and demand of consumers in a single frame, in a particular frame, and they are coordinated by some bilateral or multilateral contracts. Bilateral means if one to one contract in between the two stakeholders, so that is a bilateral contract. Or if a stakeholder make a contract with the multiple people or multiple segment, so that is known as a multilateral contract. So nowadays these kind of practices are involved in the market operation. So that's so why now the power industry is not a simple pure technical business. It is a management also. It is having a lot of business opportunity and also lot of challenges associated with this business kind of model. So that is important to understand which kind of things are involved in the power market operation. And all these things are happen in a particular place which is known as power exchanges. So power exchanges are a place, marketplace. Like for example, you have a one marketplace in the Bombay Stock Exchange, BSE. So here in that place, your all the companies are associated with the BSE, and their means stock versus production stock and the consumption versus all the coordination business relation and all the relations are making at the common place, that is known as BSE. Similarly, for the power transaction, there is a marketplace which is known as energy exchange. If we are talking about the India, every country nowadays, every country having their own power exchanges where all the stakeholders makes the contract to each other for the transaction of the power as per their business model, as per their marketing strategy. So in India, IEX and PXIL, these are the two power exchanges which is functioning. And means if you are talking about the renewable energy, so that is the part of your Indian Energy Exchange Limited. So this is the basic infrastructural detail of a modern power industry. uh, if we see look into this picture, so the in the previous slide I have discussed the concept behind the structure of the power market or the power industry, which kind of structure is there. Now the second aspect is how the market is means what are the operational strategies involved into the industry operation. So obviously, as you know, friends, there are two type of strategy. First is your regulated, and second is the deregulated strategy. In any of the market, there are two type of strategies are involved. One is your regulated, means all the things, all the transactional relation, all the business models that is governed by the some regulating authority, and there is a certain rules and regulation and protocols for the marketing and the business into the industry or the market. So that type of structure is known as the regulated industry, and here in the power industry, that is a regulated power market. So here in regulated power system, what happened means initially when our system is not interconnected, means each and every area having their own small power transmission system, their own generating station, and their own distribution corporation. For example, if you look into the back before establishment of the Power Grid Corporation of India in our country, so at that time, each and every state having their own regulated power networks, and each and every state having their own generating corporation as well as the distribution corporation, and they are working like in a such a manner that each area is known as a single operating area or single utility operating area, and the second operating area is separated from the other. But some reformations have taken out, and the power transaction in between these utility will also started in early 90s. But after establishment of a power grid, or the concept of a national grid, or you can say the central grid in India, so the market reforms, and it comes into the form of a deregulated power structure, because in this structure there is no opportunity for any generator and the distribution company to take their own decisions for the business model, for the marketing strategy, or for the profit. So the people are demanding, or the stakeholder, especially the generating corporation and the distribution companies, major distribution companies, they are asking for the deregulation in the power market. And this is happened just after the deregulation in the communication sector. As you know, initially we have only BSNL, but nowadays number of service providers are there, and they provide a lot of facility to the consumers. Similarly, in the power industry, the bulk consumer as well as the generator and distribution corporation, they are also demanding for the deregulation in the power industry. So for that purpose, it is required to make an infrastructure in such a manner where all the stakeholder having opportunity to play the business game or the marketing things in the system. So a power pool kind of concept have started, and in this you can see here there is a one central transmission corporation like power grid, and all the generation and the distribution corporations are connected with the transmission corporation. So the power it will be exchanged through the this transmission corporation by the gencos to the discos, but the financial contracts are can be made in between the not only the generation corporation and transmission corporation, or transmission or distribution. The generation can also make a direct coordination with the distribution company as well as the transmission companies. So variety of market contract, variety of marketing strategies have started in the power industry, and this type of market is known as a deregulated power market, or it is also known as a power pool structure. So nowadays, almost maximum all the developed and the developing countries having their own power pool, and all the and they are operating in a deregulated manner. So this is the basic introduction of your regulated versus deregulated market structure. Yes, I am audible. Yes, anyone? Is it audible?
Yes, sir,
Yes,
you
sir,
are
you are okay.
audible.
Okay, voice is clear, sir.
Yes, it is absolutely clear, sir.
Okay, okay, thank you. So now again one modifications have started in the power market, that is a multi-utility structure, and from this particular place the renewable energy come into the picture. Means here you can see that the number transmission corporation is single, but some of the generator gencos and discos, they have established their own group into the system. So this kind of is structure is known as a, this is a one utility, and this side is the your second utility. So a groupism in the power market, and they are especially why they are making this kind of group or set into the power market, just for generating the business, for generating the or for increasing their own profit as per their marketing strategies. So gencos and discos having a opportunity to select their own consumers, like gencos having a opportunity to select their own discoms. Similarly, the discoms have the discos having an opportunity to select their own gencos from where they can get the power. So they can make a direct coordination in between the gencos and discos, subject to one thing, कि all the technical constraints related to your transmission corporation, means the transmission lines, that should be fulfilled. So if all the technical constraints fulfilled, so they can make means they can implement their own marketing strategy. So now the number of opportunity came into the picture, like power system optimization. You can apply the AI for the marketing. Now the information technology peoples are also required for this particular market, because if you are making a contract in between the two people or the two stakeholder, you require a sufficient information. And after filtering the some critical information from the all the things, then you can make a some business model or the marketing strategy. So lot of opportunity came into the picture for the each and every kind of people, means not only the electrical peoples having opportunity, other disciplines having also opportunity to do some creative work in this type of market. Now when renewable energy came into the picture, so these renewable energy having both the opportunity, either they will make a coordination with a corporation, the Genco and this green color Genco that represent the renewable energy generation. So these two are making the coordination and feeding the power as per their distribution corporation. Similarly, the all the large scale generating corporation like India, if you can see the Adani Power, they have established a large scale 2000 megawatt solar PV system in the Madurai. So they having a opportunity to make a their own structure in this market and work as the individual power producer IPP in this market. So you can see ki one by one, step by step, the market become market reforms and giving the opportunity for all that kind of stakeholders. Not only for the conventional, it enables the opportunity for the renewable energy power producers also. So this is the overall basic things related to regulation versus deregulation. Now, what are the requirement of the deregulation in the power market? So as I already stated, if you want to apply the deregulation in the power market, so you should enable a market kind of things. So that's why power exchanges are established in each and every region, and it also promotes, means whatever the policy which is executed by the government or the regulatory authorities, that should promote the competition in the power market. It doesn't mean ki if you give the freedom to the all the stakeholder, they are taking the benefit, means you are just enabling the things in such a manner ki few of the uh, people or the few of the stakeholders they are benefited and others are not benefited. So you should means the authority should having a responsibility to enable the competition in the market and giving the opportunity for each and every stakeholder. Now investment, the advantage of the deregulated power market is what it encourages the investment in the power industry. So as you can see, nowadays number of companies, number of private stakeholders, not only the India, some MNCs are also coming into the Indian power industry system, and they want to invest in our uh, market. So that encourage the investment and it provide the incentive to the efficient participant. So and not only the competition, it enables the competition and giving the business opportunity. If suppose a stakeholder or a particular participants play a good role and provide the efficient operation or give the efficient operation in the entire power market operation, that should be incentivized. So that these kind of the things should be required for the deregulation in the power market. So now, if we are talking about the component of the deregulated power market, yes, any doubt? Because I have seen some bias. Okay, so component, what are the major components? So Gencos, Transcos, Discos, and power exchanges. So these are the four major component of a deregulated power market. I'm not going into the detail of that one because the topic is related to AI application. So I am just giving the brief introduction about the power industry. And okay, one part is missing, that is a power market. Now, what are the terminology used in the power deregulated power market? If suppose any in audience, some are interested to know that how the power industry is working, what are the operational criteria, and what are the terminologies are used in the power industry or the power market operation. So I have mentioned all the things here, and if you want to know the in some more, so you can refer the number of different literatures, and number of literatures are available on these topics. So independent system operator. So in India, power grid is known as the independent system operator. Billing and marginal cost means billing charge cost means how the power will be transferred from the generation to the distribution. So what will be the cost taken by the transmission company. Similarly, the marginal cost of the generation. So that is the important terminology. Available transmission capability of line scheduling and dispatch, congestion management, optimal bidding strategy, and structure of a European power exchanges. So these are the some terminology which is required to understand before doing some research activity in this area or in this field. So now power market, one thing is the structure, and second thing is your operational strategy. So operational strategy is basically based on the decision making. So if suppose any means in audience a person is from the management side, so they can easily understand what is the meaning of the decision making. So whatever the operational strategy you have decided, or whatever the market structure you have decided, it should be having a proper decision making capability. So in basically two type of decisions are taken in the power market operation. One is known as your centralized decision making. So if a people from the MBA background or from the management background, they can also do some research activity in this area with their because there are number of decision making strategies for the different kind of businesses and other. So you can apply those decision making methodologies for the power market structure or the marketing strategy, and you will get some fruitful result. So in this system consists of several electrical utility which controlled by the centralized dispatching control in pool, and the decentralized the second decision making is your decentralized, where the one-to-one relation means the stakeholders are making the contracts in between them, whether it is a bilateral contract or multilateral contract. So in centralized, what are the advantages of or the main features of these decision making? So if you are implementing the centralized decision making in the power market, so you require a common control center, means you should having a common control system center from where you can implement the decisions jointly operated for global solution. All the stakeholders are mandatory to jointly operate the entire system, jointly operate their individual system to get the global solution. So here the optimization play the important role. Now the information share among each participant, and in centralized decision based market structure, it is mandatory. So all the participants should share the information to each other, whether it is a technical information or sometime it will be a financial or business related information. So you can say that in the centralized decision based market, the your uh, stakeholders or the participant doesn't having an opportunity to uh, hide any information. Otherwise what happen, you will get some malfunctioning or the wrong result into the marketing operation. So entire structure can be represented by this layout where the overall thing can be controlled by a one control center which is known as ISO. For example, in India, uh, the POSCO, that is known as a National Load Dispatch Center, they having a right to control all the decision which has been taken into the market operation by the individual utilities. So you can see here all the ellipse represents the utilities, and these utilities having the different kind of contracts, multi-utility transactional market, and they having the different kind of contract in not only in between the stakeholders or in the participant, in between the utilities also. So it will be a bilateral contract or it will be a multilateral contract, and all these things are supervised by your ISO. So there is a control authority, and they having a right to take a decision for each and individual utilities. Similarly, in the second case, in decentralized decision making based system operation, individual control over the power entity means for power entity means for the power transactional relation, each and every utility having their right to make a transaction in between them, but their financial or business information, business related information, that will be shared with the control authority, and each market having their own control center. So for technical point of view, each utility having their own control center, and the all these control centers are controlled by a common control center. So individually operates their operations and obtain a optimal benefit and also a global solution for the system. So each and every stakeholder having an opportunity to optimize their own profit, their own benefit. Means here they are not optimizing the benefit or the profit for the entire system. They are optimizing their own benefits, but one thing is should be assured, their technical constraints should be under the control and as per the directed by the common control center. So only transmission system and some relevant information shared among the each participant. So that is the major beauty of the decentralized method, ki each utility have opportunity to make a contract, make a take a decision for a business for the profit and all, and each and everything will be managed by their own, and only the means the technical constraint related to transmission system and some of the technical constraint like a frequency deviation, like a active power and reactive power control. So these things should be managed by the ISO only. So in decentralized power market, the monopoly of ISO will be reduced. They are only working to look after the all the technical parameters, all the technical constraint into the market structure, but they are not look means interfering in the business model or the marketing strategy of the individual utility. So there are a lot of different kind of optimization technique and decision making strategies are used for optimizing or maximizing the benefit into the power market. So now the objective of centralized and decentralized power market is what? So here I am going to mention the sum of the objective which is generally means used in this centralized and decentralized power market. So first objective is the economic load dispatch. So economic load dispatch means whatever the power you are going to dispatch to the consumer, that should be in the economic zone. Or you can say that the cost of that power should be reduced. So that is the main important objective of this centralized or decentralized market structure, where how we can means make a economic load dispatch. So by the generation cost minimization, transmission loss minimization, minimum shift control means you are not going to shift the control into the system in a frequent manner. So if any people are from the power system background, they easily understand what do you mean by the shift of controls. Means for example, sudden demand increases. So what happened? You require to increase the generation. Similarly, the some sudden demands reduces, then you require to reduce the generation. but because in this entire structure so many generators are connected, so which generator will goes means generation level goes down, and which generation will increase the generation level, that decision making is a very important thing. And if you are suddenly increasing or reducing the generation level, sometime it will affect your economic operation, or it will affect your the cost of the total generation cost of the generation system. So you require to apply a minimum shift of control. So you should identify only those generating station where it is where by which you can get the economic load dispatch operation through shift of control. Minimum number of control shift are similar things. Minimum number of control reschedule. Sometimes the situations are not under the control and you require to reschedule all the generation and the demand. So how we can minimize the minimum number of control for the rescheduling of the generation and demand? Similarly, reactive power cost minimization, that is under the economic load dispatch objective. Determine the system marginal cost. How we can determine the system marginal cost for the economic load dispatch, and integration of non-conventional energy resources like PV, wind, geothermal for the economic load dispatch. So as you know, the now this last term is the very important nowadays. So once the system become having both the type of decision making, centralized and decentralized, so these renewable energy play a very important role. These renewable energy systems not only provide the economical power to the system, they are also means playing a very important role into the operation and control activity. So as ancillary services or as a economic load dispatch. So these are the some of the objective function you can choose for the economic load dispatch. Similarly, second major objective is to secure and reliable system operation, because interconnected transmission network is very huge one. For example, India having a very bigger system, so you should require to make a secure and reliable system operation into the power market. So how we can assure a secure and reliable system operation? So by choosing these objective functions, we can assure the security and reliability of the entire system, like branch flow control and congestion management. So that is the one of the important objective into the power market, where we should control the branch line flows, which avoid the congestion into the system. Congestion means what? Suppose if your transmission line having a capacity to transfer only 100 MVA power, and due because of any reason your transmission line is operating as a at a 80 MVA rating. Now if further demand increase of the 40 mega MVA, then you doesn't having a opportunity to fulfill that demand through this line, because you have only surplus 20 MVA and your demand is of 40 MVA. So you having access of the 20 MVA power at the load station. So for that purpose, we require to reschedule the generation, or we should control the branch flow. So that is the things for the security and reliability of the system. Now optimal utilization of ATC, same thing in congestion management. If due because of the lack of the availability of power transfer, you could not deliver the power to the consumer, that is known as congestion. And suppose if your line having a capacity of 100 MVA, but you are operating that line at only 20 or 30 MVA, then it means you are not utilizing that line for their rated capacity. So how you can optimally utilize the available transfer capability of in transmission line, that is again a major challenge into the power market. So renewable energy plays an important role in these things. Means here why I am means incorporating all those things here, because you didn't think that ki only the renewable energy is the cheapest power, so you can integrate the renewable energy for getting the economic power from the these energy resources. The renewable energy system can also play an important role in the operation and control by choosing these objectives. That's why I have incorporated all those things here. Similarly, bus voltage control. So suppose during the operation, if any any load station demands more reactive power, and if your generating station or utility didn't having opportunity to fulfill that reactive power, so the impact will be in a form of reduced voltage or the low voltage on that bus. So how we can control the voltages of the different buses, that is a important criteria. Similarly, how to utilize the active and reactive power reserves of any conventional power generating station. Each and every conventional power generating system having their own generation capacity in term of their active power generation as and its reactive power generation. So for safety point of view, we have taken some part of the active and reactive power capacities as a reserve, but it reduces your economic load dispatch, or you can say that you are not utilizing your generation at maximum. So it means what, yeah, it will affect your economic operation or the generation cost. So that's why how we can optimally utilize the power reserve, that is the important thing. Similarly, real and reactive power generation control, transformer taps, megawatt interchange transactions, HVDC link, megawatt control, fax control, and power flow control. So these are the typical electrical power engineering related problems. That's why I'm not going into the detail of that one. But if you want to discuss during this session or after this session, so I am able to uh, discuss on those topic also. So transformer tab setting, that is a method by which we can control the we can secure assure the security and reliability. Megawatt interchange means how we can interchange the megawatt power in between the two different areas. Suppose there is a one area and the second area is different one, and if you want to make an interchange in between these two area, so how we can make it optimally allocate the power transaction. So these things are important. And last, the demand management is also one of the important thing. Means during the demand, means increment or decrement, how we can apply the optimal load shedding, how we can reduce the load on a bus. Similarly, how we can decide the tariff for a consumer, because the variety of consumers are there. So on the basis of consumer priority factor, we can decide the tariff for them. And if a candidate or if a participant will make a unscheduled interchange or imposing malfunction into the system operation, then how we can penalize it. So that is also one of the challenge into the this power market operation. So these are the same important factors related to your power market operation and their decision making. If we are talking about the Indian power market structure, so in brief, I will share the detail. So initially, the initial power market is like this. All the generating corporation IPPs like NTPCs. So these are known as a IPP, individual power producer. Some of the large scale industry having their own generating corporation. So that is known as captive. And these are giving the power to the distribution companies. And this distribution company delivers the power to all the kind of consumer like urban, semi-urban, rural or industrial. Now, after reformation, one more participant added here, that is known as trader. So, what will be the function of the trader? So, as power demand increases, what happened? The all the generating corporations having a lot of burden to deliver that power to the consumer and make a establish a coordination in between the distribution company and the conventional generating companies. So these traders having opportunity, they have make a coordination between the IPPs and captive generations, and then after establishment of a contract in between these two, they deliver the power to the distribution company, and then distribution company delivers the power to the all the kind of generation. Then one more new kind of traders come into the market, and they are making the contract with the consumer and in between the consumer and uh, distribution companies. So you can see here, so, number of participants. Initially, only the three participants: Gencos, Transcos, and distribution corporation. But now traders are involved into the market operation, and they are delivering the power through means to all the consumers. Now, as demand increases, requirement of distribution corporation increases, and the number of distribution companies came into the a single area. Like in Delhi, Tata Power, BSC, and these are the two companies. Similarly, in UP, Torrent Power, Kesco, and UPPCL means all the three distribution corporations are there. Those who are providing the power to the consumers. So these traders means number of distribution companies come into the picture, and they are making and after some time they make a direct contract with the generating corporation, IPPs and captive, and deliver the power to the consumer. And they all means they also make, sometimes they make the contract with the local traders of at the distribution side. So you can see there means by the decentralization of the market structure, the opportunity will increases, and number of stakeholder, number of participants come into the picture, and they play an important role into the entire power transactional operation. Thereafter, DGs, distributed generation, means the renewable energy at the consumer side are involved, and they also deliver the power to the different area. So now this kind of picture is working here. For example, in Kite, we have a distributed generation of 100 kilowatt and 211 kilowatt solar power plant. So these type of power plants are known as a DGs, distributed generation, those who deliver the power to their own load, and if they have a surplus, they can deliver the power to the distribution companies also. Similarly, large scale renewable come into the picture, that is known as REIPP, renewable energy, individual power producers, and they also make a contract into the system. They also make a contract with the all the consumers through power exchanges. So now the entire Indian power market structure is a mixed kind of market, and due because of that, lot of not only the opportunities are generated, number of challenges are also involved, number of challenges are come into the picture, and now it is required to provide a solution for those challenges. So just for a simplicity, there is a one another opportunity. I have removed the things. There is a one thing is missing in Indian market. How to make a contract in between the power exchange and the rural distributed generation. So that is the one of the major challenge nowadays, and government of India has started so many initiative to connect our rural area through this power exchange, and means in you can say that the role of rural area in the overall power system operation. So that is the, and in future the power system means the people are thinking that why this kind of mixed feature, why not the a simple system is required where all the trader power exchange are connected means at a single place, and only the transmission corporations are connecting the all the generation and the distribution company. So this kind of features are required to be established in country, and the people are working in this direction. So maybe in future we will having a opportunity directly a consumer can apply to a particular company that we required such and such amount of power for the tomorrows, this is my load profile, kindly manage it. So in between all the traders and power exchanges, there is a one opportunity. They all should they provide offers to the consumer. Means you can take the power from our side or any other company, and according to that, for example, like a telephonic company. So all the telephone company, and also in the now in the television industry, they provide the offer for the consumer. If you take a such and such means type or recharge, so you will be benefited by such and such incentive and other things. So this kind of things the people are thinking into the power market also, but it is not so simple. It required a lot of efforts. Yes, any query till now? Yes, audience. In audience, any query? Satish sir.
If anybody is having any query, you can post it in
Because
the chat box.
this is a overall a part which is related to a power industry. Now I am going to discuss the next part, that is the renewable energy and AI. So if you have any doubt, then please discuss. Otherwise, we will go ahead.
Sir,
Yes, sir.
we'll take the question at the last of the session.
Okay, okay.
So,
So how much time I have?
so sir, you have left with 1 hour, almost
Around
1 hour.
Acha, approximate 1 hour. Okay,
Yes.
not a. Okay,
Okay,
thank
Pritesh,
you. Thank you, Piyush sir.
we have
Okay,
a
I'll,
Yes.
ample time, and if you want, you can take a break of 5 minutes. There is no issue.
Yes, sir. Yes, sir.
okay.
No issue. You can take a break of five to 10 minutes. Then we will continue.
No, it is not required right now. When I required, I will tell all the audience.
Okay, sir. Okay.
Okay, because lot of contents are here because it's a so generalized topic and people are from the different backgrounds, so it's required to add all the things here. That's why the people can easily understand ki why AI is required for the renewable energy integrated power
Yes,
industry.
sir. Yes, sir. Nowadays, also most of the software and IT companies they are involved in power
Yeah,
gen distribution also.
yeah.
Like Siemens is working continuously in this area.
Okay, I will show in last companies, AI-based companies, those who are working in the power industry. So, okay, now the next topic is your renewable energy. I'm not going into the detail of the renewable energy. It's a generalized thing. So, renewable energy is what if your energy is inexhaustible, the form of energy which is inexhaustible, like a solar, hydro, wind, these are categorized as a renewable energy, and non-renewable energy, the energy resources which is exhaustible like a fossil fuel and nuclear fuels. So it's a general classification. And if you are looking towards the contribution of the renewable energy in Indian power structure, so this is the pie chart which is taken from the MNRE website. You can see here the total 60 is still all the initiative, the around 63% of the energy requirement that is fulfilled by the thermal power plant. Electrical energy requirement will be is fulfilled by the thermal power plant, and 23 percent will is fulfilled by your renewable energy, and around 12% is from the hydroelectric, and very less 2% is filled by the your nuclear power plant. So you can see here we have a lot of opportunity to increase our renewable energy content into the Indian power market structure. So this is just a brief things ki why the people are saying that renewable energy having a lot of opportunity, because as the renewable energy integration increases, some more challenges come into the picture, some more new kind of things came into the market, and we require to solve those problem, or we require to handle those problem with by using AI and any other tool. So in general, what are the types of renewable energy? So renewable energy is basically categorized into two major type: single type and hybrid type. Single type means what? Like if you are saying that one kind is solar, then wind, hydro, and ocean. So single kind of means you are not mixing the variety of energy resources, like if you are using the solar photovoltaic or solar thermal, so that is a single type of energy resource, yeah, or the renewable energy system. If you are using the wind turbine or windmill, or in hydroelectric, greater than 30 megawatt large hydroelectric, 100 kilowatt to 30 small hydropower, and micro hydropower is below 100 kilowatt. In ocean energy, wave energy, tidal, and ocean thermal. So these are the just a categorization of the types of the renewable energy. And single type means if you are not adding adding any other form of energy with your system. Similarly, in geothermal, dry steam power plant, flash steam power plant, binary steam power plant. In bioenergy, so biogas like municipal solid waste, agricultural wastage. Similarly, liquid biofuels, jatropha curses or rubber seed, algae like vegetable oil or wood. So these are the form of the energy. These are the things from where we can get the energy for generating the electrical power. Hydrogen is also one kind of a single type of energy where the biohydrogen, PEM electrolysis, glycerin, solid oxide electrolyzer cell. So these are the different kind of technology by which we can get means utilize our renewable energy, solar, wind, hydro, ocean, geothermal, bio and hydrogen. And because it's a non-mixing of any other form of energy, so it is a single type. Similarly, when we are talking about the hybrid type, so many kind of things are maybe possible. Means if you are adding the more than one kind of energy resources in a single system, so that type of system, renewable energy system, is known as your hybrid, like PV wind energy system, PV wind battery energy system, PV wind hydrogen energy system. So I am just giving a brief introduction ki what are the possibilities by which we can generate the electricity through renewable energy. So wind PV hydrogen battery energy system, then PV hydrogen battery hydrogen energy system, PV hydrogen battery energy system. So lot of research are already available on these direction. PV integration with the diesel and battery system. So most of in the standalone system in the rural area, we are using the PV diesel and battery energy source energy system, and that is the most popular energy system, you can say, for the rural area. Second, the wind diesel hydro energy system. If you are integrating here, we are integrating the all the different kind of energy resources with the PV. Here, the adding the different kind of energy resources with the wind energy system. So wind diesel hydro, wind diesel battery, and wind hydrogen. So these are the different kind of hybrid type of renewable energy system. So if anyone wants to be work on this kind of technology, so they should having the awareness about the individual kind of energy resources, how we can get the means conversion process, means from that energy resource to electrical energy production. And whenever you are integrating the two or three energy resources at the same time, so what are the basic criteria which is required, and what are the challenges faced by the practicing engineer, you should be aware about those things and you can work on those things. Now now the main topic, that is a AI application in the power industry. So when we are so there is a very small I'm going to represent a very small historical background for the AI application in the power industry. Most of the people, and especially our student, when we are talking about the student, so they are saying AI is the very advanced and new thing, and now the people are looking towards the AI. But friends, AI application in a power industry is not a new one. In early to mid 90s, 80s, the power system engineers, they are using the AI techniques to solve the complex problems into the power system. So in power system analysis, there is a one topic, computer methods in power system. So where means in that particular area, the people are working on the different soft computing technique, like AI techniques for solving the complex problem, like parameter evaluation, efficiency enhancement, optimization into the power network, economic load dispatch, optimal power flow. These are the various area where the already the AI has already implemented. But nowadays the people are talking about the machine interface, means how we can interface the AI, use the AI for the machine interface into the power network. So presently artificial intelligence help in handling the many constraint of the power system. So whenever we are talking about the power system optimization or optimal operation of power system in power marketing, or during the marketing operation, either it is a centralized, decentralized power pool, or bilateral, multilateral market, so anyone. So how we can handle the constraints by using the artificial intelligence, that is important. For example, constraint, suppose if your generator having a generation limit, now active power limit is 100 megawatt, and you are just making a 10 megawatt power as a reserve. Now during the any contingent situation, if you require a sudden amount of power, it is approximately 3 or 4 megawatt. So how optimally your all the generators utilize that reserve for making managing those contingent situation, that is an important thing, and AI can play an important role in that type of things. So I have already told you means in economic load dispatch nowadays people are working in this direction. Now load forecasting is one of the important area in the power industry, means where uh, because and it the importance of the load forecasting become more useful in the power industry after integration of the renewable energy and after implementation of deregulation in the power market. Because in the deregulated power market operation, the all the stakeholder having their opportunity to optimize their own generation and the consumption level. And if you are not properly forecast the load condition into the system, then what happen, maybe your transmission network will be collapsed. So in conventional power system, sorry, deregulated power system, load forecasting is used for and making means making the power balance condition into the market. And after renewable energy integration, because renewable energy is known as a variable generation, and if you are making a contract with a renewable energy generating station, so you should having a proper forecasted load value. Otherwise you can't make a direct coordination with a renewable energy based power generating company. Similarly, optimization of generation scheduling, transmission capacity and optimal power flow. So these are the some area where AI can be implemented. So real and reactive power limit of generators, bus voltage and transformer tab, these points means you can see here initially these points came into the picture due because of the deregulation in the power industry. Now for for solving same problem, the AI has been implemented. Means initially the conventional numerical techniques or the conventional optimization techniques are used to solve these problems, but nowadays the AI techniques are used to solve these problems. So that is the importance of the AI in the current power industry practices. Now why the AI is required in the power industry? So for industrial development with the power system expansion, stability, strengthening, reliability, and technical advancement. I think after these discussion, we can easily understand ki what why these are necessary. Industrial development and expansion means as you increase the means your day by day your power system is expanded, transmission extension, generation expansion. So due because of that you require to and a number of constraints come into the market. So for handling those constraints we require the AI. Stability, assuring the stability of power, strengthening reliability and technical advancement, we require the AI technique. Similarly, the selection of appropriate parameter for better dynamic response of power system. Whenever you are going to apply the power system operation and control, you are going to control the entire power market operation, especially technical control. So you require to evaluate or identify the appropriate parameter from the system. In a simple language, in a control system, what is there? In a control system diagram there are several components and each component having their own parameter, and whenever you are going to apply any control strategy on that, so what will be your objective? You should identify the parameters of that system and then control it or change it. By changing the parameter, by changing the variables, you can control the system. Similarly, in the power system is a system, and if you want to apply a better dynamic, if you want to get the better dynamic response, so you should having a proper control strategy, and AI can play an important role in this direction. That's so why in nowadays the growth of power system complexity and activeness of the power networks are increased tremendously, or and that's so why the AI become a very fascinating and you can say the very attractive part of power system operations. Second, the complexity of the conventional analytical technique for the power system analysis provide slow computational result and conclusions for acquiring data, process for information management and remote devices. If you are talking about the conventional analytical technique, they are slower and sometimes they will take more time to get the conclusion for getting the data or process any information or applying the management for remote control devices. That's why AI is more useful in that direction. So we require means as the necessity is the mother of invention. So AI can develop a fast optimal solution with the help of sophisticated computer tools and apply to resolve all aforesaid problem for large system. So you can solve the number of technical problems associated with the power system network by using AI techniques. So okay, okay. So these things are completed. Okay. So now the next topic is your AI technologies, and these are the very you can say the attractive topic for our student. Means nowadays all the students are looking towards these technologies, uh, but what I found, the students are interested to learn AI technologies, but how these technologies can be implemented for the core domain. For example, my expertise or my area of interest is the power system and renewable energy integration. So when I have decided to work with the student on this topic, AI technologies, then one of the my means the my objective is to motivate my student to do means learn AI technologies, but apply these technologies for the renewable energy. Otherwise, if you have a very good knowledge in AI and use of AI, but if you don't know where you can apply, if you don't having a domain in knowledge, then it sometime it will be a tough or it will be a complex, it will create a complex situation for us. Means I have a tool, but where we can apply this tool we didn't know. So means especially the students, they are means it is a, just a gentle suggestion for all of you ki if you are interested to work in AI technology and if you are interested to do some work in the renewable energy area, so first of all you should understand the basic concept related to the power system and the renewable energy, then apply or integrate your AI technologies. Or you can start a interdisciplinary project activities along with some core people, means the it will be beneficial. So in a teamwork, like a industry, they having a team with a variety of people and they are implementing any topic or concept for getting the result in this direction. Okay, so now this is the AI technology. So there are these six type of AI technologies, as you know: machine learning, deep learning, natural language processing, robotics, and fuzzy logic and expert system. So these are the six major type of AI technologies which is used by the all the industry, or you can say that everywhere all these kind of technologies are available. So here I am not going into the detail of these technology because I think I am not a right person to explain the basics and the detailed deep knowledge on these technology, because I am a power engineer, so I am using these technologies. I am using these technology as a tool for my research activity. So I always try to learn the things, how we can use these technology for my application, but how we can develop these technologies or some modifications or interconnection of these technologies means with different domains. So I think it is a not appropriate for me, or it is not my area. So I am just giving the brief into things, and I am showing the things means how these technology can be implemented for the power industry, especially the renewable energy application, and on which research area or the topic we can apply these things. For example, machine learning. So machine learning is a science of getting machines to interpret, process, and analyze data in order to solve real world problems. So these are taken from the internet. So those definitions are taken and the references are given here. But and in machine learning, basically it is categorized in a three parts: supervised learning, unsupervised, and reinforcement learning. So as you know, when we are talking about the learning methodology, so the three type of technologies are used, three type of methodologies we are using: the learning in the supervision of someone, or learning by itself, or learning by the reinforcement from the other one. So these are the three techniques. And especially when we are talking about the renewable energy integrated power system, so these technologies, machine learnings, are basically used for the forecasting, parameter evaluation, selection of control variables. So in as you know, means I have given the all the information ki what kind of means control strategies, what kind of things are required, or the different objectives are required to get the reliable and secure operation in a power system. So as you know, load forecasting or the renewable energy forecasting is a very important thing. So nowadays people are using the machine learning for the load forecasting and the renewable energy forecasting. Similarly, parameter evaluation. So a simple example I have taken here, means I will taken here. Suppose if you want to evaluate the parameter of a transmission line during the operational condition. Uh, Parameter of transmission lines are basically inductance and the capacitance of the transmission line, and resistance having a very nominal value. Similarly, the shunt capacitance. But the power engineers know, they know very well, means the parameter of any conductor is not only depending upon, especially inductance and capacitance, is not only depending upon the material and the current flowing into that conductor. It is also depending upon the structure of the transmission line, which kind of structure you have to take in for making the transmission line. Similarly, what is the current status of the what is the present status of a current flowing into that conductor, and what will be the current situation around means of the environment which is surrounded to the transmission line. So lot of things which is affected, means your transmission line parameters are affected by the some external forces or the external environmental condition. So how we can evaluate the exact parameter of a transmission line? So here we can use the machine learning. So from the database you can use means sorry from the using the machine learning, we can evaluate the parameter of the transmission line in a continuous manner. Similarly, suppose if you have a number of variables, control variables in a power system networks, there are so many control variables. So now which control variable is suitable for controlling any contingent situation into the into the power system? Suppose for example, if you have a problem, you have a constraint related to uh, excess of power demand. So now you require to reduce the load on a power network. Now means now and as you know, there are several load stations are connected with the power network. So which load station you require to reduce, or you is how you can apply the optimal roasting for the system, and optimal load shedding of the load shedding into the system. So for taking these kind of decision, first of all you require to select a particular variable, or means which load is suitable to uh, reduce or apply for the load shedding or the load containment. So this kind of problem can be easily solved by the machine learning. So a person who having a ability to implement the machine learning, so or a knowledge how to use the machine learning tool, so they can solve these kind of problem in the power industry. Similarly, deep learning is nothing else, it is a neural network based technology. So in power system, means neural network is not a new one. As I already said, in early 80s and mid of the 80s, people are using the neural network for solving the number of different kind of problem into the power system. So nowadays, again, the people are using the neural networks, not only the single neural network, uh, means hybridization of these technologies, means machine learning and deep learning, means for the solving these kind of problems. So power system optimization, real-time control, and security analysis. These are the area where you can apply the neural networks. Similarly, neural language processing. So natural language processing, basically it is refers to the science of drawing the insight of the neural natural human language in order to communicate with machine and grow business. So nowadays the people are talking about the chatbot and communication in between computer to computer, communication in between the two machines. So in nowadays power means if you want to implement uh, automation into the operation of the power market, or you if you want to provide us customer support in a power market. So these NLP technologies are mostly used by the industry for solving these type of problems. Robotics is again a one of major area, and especially it is used for the automation into the power industry. So nowadays automations are involved at each and every stage. Similarly, in the power industry, home automation, substation automation, similarly generation control automation, boiler feed pump automation. Lot of things, means each and every segment, number of segments are there where you can implement the automation. So robotics is the one of the AI technology by which you can implement the automation in the power industry. Fuzzy logic is not a new one; it is again a very old one, and basically it is used for the system control. So in the control operation, fuzzy logics are mostly used. One of my BTech student, he have implemented the fuzzy logic for the pitch angle control of a wind turbine and published a one paper in IEEE Explore also, and two lecture notes in the stringent nature on the basis of that fuzzy logic technology. So they means the student have implemented the fuzzy logic technique for the wind turbine especially. So you can see that if you are if you have an interest to learn the AI technologies, so and if you want to apply the AI technologies for the renewable energy, so you should know that where you can implement these kind of technology. So if for the control problem, for solving the control problem, especially fuzzy logic techniques are used. Okay. Similarly, expert system in power system, initially all the things are based on the expert system, and nowadays because AI, neural network, and fuzzy logic and machine learning come into the picture, so most of the things are converted based on these things. But initially the power system operations are based on expert system. So information management, contingency management, and protection. But nowadays uh, means everywhere you can implement the machine learning, neural network, fuzzy logic, robotics, or anything. But when you are talking about the contingency management and protection, so you should rely on the expert system only. Even nowadays the power engineers are only trusted on the expert system in case of power system protection. So if you are interested to work for the power system protection, then you should having a ability to implement these expert system. So after understanding these things, some of the few questions come into our mind. Means what are the challenges in integration of large scale renewables? Means if you are going to integrate a renewable energy, large scale renewable energy in a power network, so what are the challenges? Similarly, what are the measures is required to mitigate these challenges? If you apply these, means if you are integrating the large scale renewables, so what are the measures are required to mitigate these challenges? Similarly, what are the factors affecting the success of renewable energy? How AI can assure the success of RE? So these are the few questions which came into our mind. So how AI technology can improve the renewable energy sectors, and what are the application areas, and what are the available AI technology used by the industry? So these are the few questions which came into our mind. If we are implementing, if we are integrating the large scale renewable with the power network, so what are the challenges? What are the major issues related to the power network? And then how AI can solve these problems? So, sir, because I have taken lot of things here, So I'm not going into the core technical part of this particular topic, like challenges of integration of large scale renewables. I am just showing the all the things. Number of things are means number of challenges faced by the power industry while integrating the large scale renewable. But how AI can useful, or how AI can play the role to solve those problems, I'm going to discuss those part only, because I have only very less time. It is a 4 o'clock. So next 15 minutes I will cover the all the things. So that's why we can able to discuss. I can able to take some questions from the audience in the last 15 minutes. So there are two challenges into the integration of large scale renewable. One challenges which is related to grid planning, and second challenges in grid operation. So you can say that if you are going to integrate a large scale renewables, then you are facing the two major issues in the grid planning, means like a transmission expansion, how to integrate the renewable energy, where we integrate the renewable energy. These such kind of problems come into the mind. And second, during the operation of the grid, what are the challenges? So there are several challenges related to grid planning. I'm not going into the detail of that one because it's a pure power system topic. But just in a brief, you can understand if you are if you plan to integrate the renewable energy with the your main grid, so you are facing the challenges related to not due because of the two things. One, the renewable energy generation locations are far away from the load center, so you require to collect the power from all the renewable energy centers to the load station. That is a major challenge. And the second, because uh, these renewable energy generations are not a controlled generation, these are the variable generation, environmental dependent generation. So whenever you are going to planning for the coordination bilateral contract in between the generation and the distribution, so sometime due because of the lack of power generation or lack of the demand, some coordination or dispute come into the mind. So this came into the market operation. So these are the major challenges related to planning. Similarly, if we are talking about the challenges with the grid operation, so as I already said, the how to utilize the reserves, spinning reserves, then if sudden drop will be happen into the renewable energy, then how we can manage the situation. Similarly, how the we can manage the ancillary services like active and reactive power support for the system. Second, RE, they means they having a major issue ki during the fault condition they are not supporting the system, they are just disconnecting from the system. So how we can manage the situation of right through problems, and right through means how we can improve the right through capabilities of the renewable energy. Harmonic is a major challenge. So at the point of common coupling, where you are connecting your renewable energy, the harmonic is a major issue. So these are the some technical issues associated with your grid operation, or the challenges in the grid operation. And these are required very detailed knowledge and detailed practice of powertronics, power system, and how we can control and manage the constraint into power system. So these kind of things are required to be understand. So so these are the some points. I'm not going into the detail because sir, Satish sir, if any audience wants to be take these slides, so you can share with them so they can collect the information, means what are the similarly the mitigation management. So for these points we have already covered. These are the things by which we can easily control the easily manage the situation of large scale integration. Now, factor affecting the success of RE, there are three factors. If you are expecting the maximum power from the RE, catching maximum load through RE, and if your conversion system having maximum efficiency, then you can say that your renewable energy will be success. Now, the main important thing is the role of AI in RE. So role of AI is the AI technology develop smart entities that will produce more accurate prediction for the complicated problem. So if you have any more complicated problem, then you can implement the AI. there are so many number of problems as I already given in the previous slides. So for solving those problems, we can implement the AI technologies. AI technologies, especially if the problem is related to your modeling, identification, optimization, availability prediction, forecasting, control of a renewable energy system, then you can apply the AI technology. Created opportunity to design and develop advanced technology. So these are the some area where you can apply the AI technology, like a modeling and parameter estimation means if you want to model any power system, then modeling and parameter estimation can be by the help of AI. Net load and RE forecasting means load forecasting and renewable energy forecasting problem. Line loss prediction, you can apply for the line loss, maintaining system reliability and system efficiency, and renewable energy operations. So how we can apply means renewable energy operations through AI technology, integrating the RE and battery storage system, uh, yeah, the intelligent BMS, battery management system. You can work on this direction, predicting equipment failure, decision process for grid operators, energy management, optimal sizing, and performance evaluation. So these are the some area where you can apply the AI into the renewable energy operation. Also, AI create the revenue opportunity for energy and utility sector. So there are so many software by which you can use large data set analysis, identifying patterns, detecting irregularities, making precision prediction, learning based decision. So in these area we can these are related to your revenue opportunity, or you can say that a business model. So AI can be useful in that direction also, enabling customers centric solution. So you can develop a technology which supports the customer using AI, and in operation and maintenance also predict downtime, which can extend the lifetime of equipment. So operational scheduling of the all the equipment into the system, you can plan based on the AI, facilitating active customer participation in demand response program. So these are the some area by which you can where you can apply the AI. Improvement in RE sector, AI enables the following feature: smart, centralized control centers you can develop by using the AI. Improved integration of microgrid, you can integrate the microgrids. Improved safety and reliability, and expand market. So these are the four and smart grid with the intelligent storage. So these are the five area by which you can improve the renewable energy sector. So you can choose any topic and start your research activity. These are the some application area. Here I have taken only three examples: solar, wind, and biomass, where we means which kind of problem we can apply the AI things. So I have covered the things here only. AI approaches solar energy in the direct means solar irradiance prediction. You can apply radiation prediction, PV power prediction, PV energy prediction, MPPT of PV array, solar tracking, size optimization of power system. So AI can be directly used in these kind of problems, solving these kind of problems. Similarly, indirect approach: design of solar water heating system, performance assessment of a solar water heating system, daily ambient temperature prediction, and building energy prediction. So these are the area where you can apply the AI with solar energy system. Similarly, wind and bio. So in wind energy system, wind speed and power prediction. So one of my student have worked means on this particular topic. Then design of wind generation system, missing data interpolation, then wind turbine fault diagnosis, risk optimization in wind energy trading. So the people who are interested to work for the wind energy system, they can apply the AI approaches for solving these kind of problems. Then AI approaches in the bioenergy. So these are the some area where you can apply the AI technique for solving the problems associated with the bioenergy. Available AI technologies, I am not going into the detail of this one. These are the some companies, those who are providing the AI solutions for the renewable energy market, like Energix, Barcelona, Spain. They are providing the support for data mining, web based energy forecasting application. So if you want to work on the technology which is given by some standard company, or given means they are giving the opportunity to work as a consultant also. You can submit your solution, you can discuss the different new thing with these companies also, like a Google Deep Mind. This is a very famous thing. Deep Mind AI is the application of Google, and that works to improve the energy uses. For energy management, they are providing the AI solution like Excel. They are providing the accessing the weather reports and higher accuracy and well detailed manner. So they are collecting the data for the weather situation and all. Similarly, work they are just they are also providing the AI solution for energy signature, means from the different energy resources, which kind of patterns you are getting, means how the energy resources are get exhaust, or how they perform energy conversion system. These kind of things are provided by these companies. Similarly, Verdix Technology, they provide the software platform that leverage AI to optimize energy consumption. And similarly, Power Scott, they provide the customer education. So renewable energy and AI customer means education, they provide the power by the Power Scott. So you can go on the website of the Power Scott, and you will get a lot of information related to AI application in field of RE. So this is the current status of market. I'm not going into the detail how the renewable energy uh, goes means slowly increased in Indian system. Now only I have taken a one point here, that energy demand is expected reached by the 15,820 trillion watt hour by 2040 in India. And for means fulfilling this particular demand, definitely we require the energy we will depending upon the renewable energy resources. So in future, lot of energy renewable energy based system come into the picture, and they will integrate with our power system or the power market. So at that time, maybe some more new challenges come into the picture, and lot of research based opportunity we will get. So you can means the people from the different stream, they can jointly work on this particular topic and start some research and development related activity. So now just I want to show one of my case study which has already implemented in my laboratory. This laboratory is in front of cafeteria. So figure I have shown that figure here only, just recall you there is a PV panel which is connected with a center of excellence. So inside that center of excellence, means we have developed a microgrid system in that laboratory. Some of the my students, they are working on this project. If, suppose our target to is to design a smart standalone small scale microgrid for cooperative farming and micro agriculture. So this project has already completed. This is a basic control power module diagram, and it is implemented by a Shashwat. It is a BTech. He is a BTech third year, fifth semester student. So the all the power modules is created by the that person. And the second part, now we are trying to integrate the load forecasting with our microgrid model. So load forecasting is what actually basically you just collect all the historical data, and then select some data which is fruitful, and calibrate your model, and then forecast for the upcoming days. So this slide I have included today only, because it is a great achievement for us. My one of the student, Akash, BTech fifth semester, he have implemented a uh, SARIMA method, that is a seasonal auto regressive integrated moving average series time series algorithm method for forecasting the load. So his test is completed and his model is properly working. Now we are trying to implement this forecasting model for our microgrid system, which is already installed in our laboratory. So this is the overall thing related to my presentation. I know the time is too much. Lot of content I have taken uh, for this presentation. uh, actually when I know that the people are from the different domain, so I have think means I have think that why not to collect all the information which will be useful for all. So that's why I have included a one quotation here: make a joint hand, AI experts and experts from the core. So without making a joint effort in this direction, if you want to work in the renewable energy area, including AI technology. So definitely you required the experts from the different domain. So students, it is suggested, or from my side, you just make a interdisciplinary group and try to work in this direction. So and in future it is a upcoming area. Lot of things, lot of new things are coming into this area, means renewable energy integration and power industry, and lot of job opportunity is also available. But one thing is important: you should having a proper skill related to that. So thank you once again